Okay, Gracie, what did your group say about domain and range? Domain is the x value, and range is the y value. Were there any other phrases, words used for domain and range, Leah? Okay, input is domain and range is output. Excellent. I interchange between both of those. So I talk about x and y's. I also talk about inputs and outputs. What I like about x and y is it kind of tells you where you would be looking at on the graph. So if you're trying to determine the domain of a function, you're looking along the x-axis, that's left and right. If you're trying to determine the range of a function, you're looking along the y-axis up and down where you see your graph. Okay, so that's helpful. Here's an example of a graph of a function, and we're going to identify its domain and range. And this function has been, maybe we could say truncated. We kind of cropped off the ends there so it doesn't have like arrows going in both directions. So starts here at this point, looks like -1, 1, and then looks like a polynomial function because of the terms there, and ends at this point, looks to me like 5, 2 maybe. So if we were talking about domain, remember domain is the x values, it's the inputs. You're looking left and right on the graph. So we see the graph appear in this section between -1 and 5, and then you've got to look at the ends or the endpoints of the graph to determine in interval notation, is it inclusive or exclusive? Are you going to use brackets or parentheses? Over here, what are we going to use on the left? Brackets. So the first part of the domain is -1 inclusive. Okay, so domain is -1 inclusive, using a bracket. And then domain appears to go all the way to 5, and at 5 we would say inclusive, exclusive. Exclusive, because we're not really at 5, 2, that's like the boundary, but we don't actually get there. It's an open circle. So we would use parentheses. So we would say something like this. If I had not truncated that graph, if there were just like arrows on both sides, then we would use what for our domain? The infinities. Negative infinity to positive infinity, both with parentheses. Okay. What part of the graph are you going to focus on to determine range? The y's. And what points on the graph specifically? The highest and the lowest points, like the domain or the minimum and the maximum, right? So if we're doing range, we're not just looking at the y values of these like most left, most right. We're looking at the highest and the lowest point. So we're looking at this point right here, which appears to be our minimum. Maybe like happens at 2.5, -3. And then we're also looking at this point here, which appears to be our maximum at 0.3. Both of those were closed circles, right? Actually got to that point, so they're going to be brackets inclusive. And what values would we put in for range? -3 to 3. Now we're focused on the y values. Okay, it goes as low as -3 for y and as high as 3 for.
I know which color.
Anybody want to answer that for Turner? Bailey?
Smaller or less than number?
Okay. Always put them in order of the number line. So lower numbers first, higher numbers second. Very good question. Very good answer. Any other questions, concerns? You okay?
Yeah.
Okay. Okay, on my next example, if we were going to do the same thing, pick out domain and range, what do you think could be like an issue for some people if they're doing domain and range? There's a break in the graph. So what are you going to do if there's like a gap in your graph? What does that mean in interval notation? Alexander? Yeah? I shouldn't have started talking. What else were you going to say?
So like the domain for that would be like, it'd be like negative infinity, like 0, and then it would go from 1 They would have to be with, I don't know. I got that part.
Brackets, because these points are
Close.
closed. And so the gap is that issue, like what would most people struggle with immediately? There's a gap in the graph. Is that okay? Yeah, you're just gonna have like different intervals. Bailey, you wanna say something? Oh, neither brackets in the union? Is there a point at 0? No. At x equals 0? Ah, yeah, this 0 should be -1. It goes from -infinity. Remember, you're looking left and right, so you're looking at the x value for a domain. So your number should be the -1 and the +1. Okay, so we'll change that real quick. It should be -1. Sorry, the smartboard is on its own time today. Okay, so that might be trouble for some people. What about range? Something to infinity.
And then you wouldn't need to put the number.
Yeah, so like even though there's two parts to the graph, they're both like have the same minimum, and then they both extend to positive infinity. So you don't even really have to look at both of them. You're only looking at one, and you only need to write it once. 0 inclusive, because it's still that closed circle, right? So use a bracket and then towards positive infinity. And that covers both branches of that graph. So you only need one. Are we okay with that? Any questions, concerns? Okay, next thing we want to talk about after domain and range is it a function? That's what that says. Is it a function? And so again, I'm going to have you do just a little bit of recall from Algebra 2 and before. What is a function? How do you know something's a function? And have a quick conversation with your group. What's a function? How do you know something's a function?
There could be multiple ranges. Could be multiple with the same number. Yeah. That's like just like in the and then you can have like yeah, like an
Okay, is there a volunteer from any group that thinks they can give me the definition of a function? What is special about a function? Okay, Olivia. I love that definition. Every input has one output. Or exactly one output. Could every input go to the exact same output? Yeah, if that were the case, if they all had the same output or they all had the same y, it would just be a horizontal line. Okay, so that would be fine. But outputs can't have more than one input. Okay, that makes it not a line or not a function. Does anybody remember how they can check if something's a function? Molly? Oh, the vertical line test, specifically on a graph. I love that. So I would write something down in this section about vertical line test. Okay? So vertical line test is your friend. And what are we checking? And I've got 3 examples from the textbook. What are we looking at in the vertical line test? Like, what are we trying to see when we do the vertical line test? Kathleen? The vertical line touches at least one point on the function. Intersects the function in at least one spot. Or exactly one spot. Okay, I'm gonna make you choose. Which one do you want? At least. So is this first one a function or not a function? It is not a function. That's correct. Why is it not a function? Because it crosses more than one point, right? It crosses 2 points. So we should change Kathleen's statement to be the vertical line can cross at most 1 point, right? Okay, so 1 point is it. If the vertical line crosses more than 1 point, it means that specific x value had 2 outputs, right? If I was this value, which looks like x equals 2, I don't know if I should be in the negative for y or the positive for y. I've got 2 outputs, so that's not a function. Okay, so it should cross exactly or at most 1 point. Is this a function? Yeah, it looks like a polynomial. And if we move the vertical line across the function or across the graph, it's only going to cross at a single point every time. So that's a function. And what's going to be the trouble spot in the next graph? It doesn't intersect at all in some places. Is that okay? Yeah. So is that last one a function?
Yes.
Yes. Now, it might be a different kind of function than you're used to seeing. We call it maybe discontinuous. It's not a continuous function. You actually have to pick up your pencil and draw a second piece, but it's still a function. Because in all the places that it does cross a point, it only crosses 1 point. Okay, so pretty basic, vertical line test. Last thing we want to talk about today, still something that you know from your previous year, Algebra 2 or Algebra 3. Finding zeros. So in Algebra 2, Algebra 3, Honors Pre-Calculus, you get this question a lot. Find the zeros of this function. Find the zeros of that function. Okay, so a lot of times that's your direction. What does it mean when your math teacher asks you to find the zeros? So again, I'm going to ask you to do a conversation with your group. See if you can come up with a plan. What the heck does it mean when we say find the zeros?
Oh, yeah. Yeah, we So it's like what things that cancel out like the next to make the y or the things that cancel out y. Finding out what.
Okay, Max. What does your group say for finding zeros? What does it mean?
It's like finding out what cancels out like the x to make it 0, or what's canceling y to make 0.
The value of x that makes the function.
Yeah.
And you could think about that like f of x or y equal 0. Okay? So, yeah, you're kind of like, you're saying like cancel x, it's like solving for x, right?
Mm-hmm.
You're finding x that makes the function equal 0. Did anybody else say anything else for finding zeros? Yeah, if they're real, if you come up with real answers, real zeros are x-intercepts. So that's probably, I would say, the most common response to that question.
Good morning, Titans. This is Mr. Steele, the principal of the St. Elizabeth High School. I just want to thank everyone, continued thankfulness for their patience yesterday as we transitioned into the new 4-lunch system and Titan time. The teacher you have this period has given you a new copy of your schedule. It's in green. This is the most up-to-date version of your class schedule, and all others should be disregarded. And the reason is we've made some changes to time assignments and also locations. So be sure to double-check your schedule to get the right room number. Also, remember to take a look at the roadmap on the back of your class schedule and start with your Titan time. That's the first step. If you look at your Titan time when it's supposed to be, be, then look at the roadmap on the back. They'll walk you through where you need to go. That is it. We'll tell you where to go during this period. Remember to move to your tank time promptly. It's considered a class. Attendance will be taken. And again, thanks everyone for their patience and flexibility. Further announcement reminders will be coming up. We're getting through this. Now go learn.
Okay, so we'll do one quick example, and like you have studied in Algebra 2 a lot of different ways to find zeros, or Algebra 3, basically at the end of every chapter you did some solving section, and that was finding zeros. So this is an example of something that's quadratic. What options do you have to solve quadratic equations? What are some methods you can use? Factoring or quadratic formula, right? So if I see this, I'm going to think about factor or quadratic formula. I'm going to review really quickly my factoring method, which is guess and check. So I would set my f of x equal to 0 to find my zeros, my y, and then I would look at this and I would check for factors. And in guess and check, you might have a different method and you can use that other method. In guess and check, I just look at the first term, 3x squared. What could I multiply together to get 3x squared? This one's pretty easy, 3x and x. Then I skip the middle term for right now and I go straight to the last term. The last term is negative 16. What kinds of things multiply to make negative 16? 8 and 2, 4 and 4, 1 and 16, 1 is positive and 1 is negative. So now I'm tasked with what numbers can I put in so my outside and inside terms will combine to make 22. Okay? And you can, some of us can put in like 4 and 4, that'd be 12 and 4, that's not going to work. 8 and 2, and think about replacing them in different spots. If I do 8 and 2 right here, that gives me 24x and 2x. That'll make 22 if that's negative. One of them has to be negative and one of them has to be positive, right? So I need that negative 2 to be negative, or the 2 to be negative, and I need the 8 to be positive. Now give me my middle term. It'll also get me my negative 16. If you have a different factoring method that you like to use, you can. Then I should take my factors and set them equal to 0. So we're coming off of summer. I know that can be a challenge. Like, how do I solve all those equations I did last year? I have no idea. You'll get back on that, journey, right? And it'll be like, oh yeah, I remember that. Okay, I've seen that before. So definitely take some time to work on your homework this evening. That gold sheet that I gave you, your homework for today is like page 56. Some of the problems are bolded and underlined. Some of the problems are not. If you look at the bottom of the gold sheet, it says the bolded and the underlined problems are required. The other problems are additional problems for practice. I would get in the habit here at the beginning of the year, if you can, do all the problems. Then you'll get all the practice you need to be prepared for quizzes and tests. Start off doing as much as you can, and then you can kind of restrict yourself to required problems when you start to get busy. Okay, but try to start strong, try to start doing all the problems. Tomorrow we'll do a little section on 1-5, then we've got that summer packet quiz. Focus on page 1 through 4.